this video, we're going to talk about a particular kind of shortcuts, a so-called loop. Loops take care of a problem of iteration. Iteration is sort of a standing concept in data science and programming. It basically means doing something over and over again, right? Just to give you a very practical example, if we go to our data, we're going to load the tidyverse. We're going to set the working directory, load our beloved students data set, and we're just going to restrict that data set to only the information on grades, right? You know how to do that from previous sessions. Now, let's take a quick look. We have here the grade point average GPA for the year 2010 to 2020 for all of the 1,000 students, right? Now, imagine you want to take the mean of this column, right? You want to get the mean average grade point average for 2010. But you also want to get the mean for all of the other columns. So you would basically repeat the same command for each column separately, ending up with 10 rows of creating that mean. Obviously, this can be done much quicker. One way that we've dealt with this in the past is actually what's called vectorization. So you reshape the data into a long format. Please check out previous weeks where we taught how to do that. So basically that means putting each year below each other and then adding a grouping variable that indicates which year the grade point average information is from. And then you just do one mean for the whole column, but grouped by the particular year. This is how we dealt with it in previous sessions. Now I want to show you a different approach just to introduce a new concept here, which is called sort of a loop, basically an iteration shortcut using the across function. Okay, so we go back to R, and what I did here is just selecting all the grade point average variables by just specifying the range here. We could have done the same by using a shortcut here called contains GPA. It would produce the same thing, right? It just selects every column that has the GPA character, that name in it, okay, with the contains function. You could also do the opposite here. For example, let's create a data frame called non-grades that includes all the variables except for the grade point averages, right? Because we added here the exclamation mark, which means not contains this one, all right? Okay, first, let's use the across function to actually turn every variable in that Y format for every year, right? Let's turn that into a numeric. We know how to do that for one column right now, but now we're going to do it actually for all of them. Okay, so you're going to take the grades data frame, and then you're going to mutate it, and then we use this new across function, right? The across means whatever I'm going to tell you to do it across these particular columns, right? We do it across. Then we use another shortcut, which is called where. So it could also be called when, let's say. So when the column is a character variable, right, or if, in a way, then, comma, as numeric. As numeric is another function that shows whatever you put into this function as numeric type, right? So basically, if you read this out, this means that change any variable that is a character variable in every column to numeric. Okay. Let's check that out and use the structure function to see whether it actually worked. And we see it did. Now they're all numeric variables. Okay. You could have also done the same using a different shortcut, using, for example, starts with GPA, because all the column names starts with GPA, or contains, right? They are just different ways of actually picking which columns you want to do your operation on, okay? Now, if you want to only choose selected variables, for example, you could pick another, you could actually specify the name of each column rather than having it, you know, whatever it contains or what it starts with, or telling the range of the columns, what they are, if there are particular columns that are not together, right? You could actually just input a vector, a list of column names in the C vector, okay? within the across function, name the particular variables, and call the same command. That's another shortcut. All right, now finally we want to get the mean for all of these variables that are now in numeric format, right? So remember the numeric format, the transformation is saved in the data frame called grades1. So then we use the summarize function, which you already know, and within the summarize function we use the new across function. Again, we specify the range of rows. We tell this function what is it that we want to do with the column, right? And we want to tell it exclude all the missing values, because remember, if you do take a mean, it is important which values are taken into account, whether means are taken into account or not, right? So let's do that, see what happens here. It creates a new data frame called mean grades. It actually has one observation, one for every column, right? So what this basically does is a shortcut for a loop iterating over every column. So it's saying, take the mean, do this, take the mean across these columns, right? So this is the shortcut that it's doing. We could also do the same thing by another variable. Quick reminder on some of the data management skills we learned in previous sections. Let's go back to the mean grades. Let's override the mean grades data frame based on the initial students one. We select the GPA and the sex. We convert them to numeric format, we group by sex, and then summarize all of the GPA columns using the mean. Let's see what that brings us. Mean grades. Okay, now we see we have 3 rows, male, female, male, and not available. Okay. All right, this is it. I mean, as summary, you can use the across function, right, to basically iterate over columns within a data frame and make your life a little easier instead of repeating the mean function for every column. You can do it in one sweep. Remember, another way to do this is actually vectorization, to restructure the data just into one column, grouped by another variable, and then operate the same command just once on one column. So try it out with your own data and see if you can really speed up your process that way.